power up this transmitter. Receiver is receiving signal from this place is more than 10 km away from our transmitter antenna. From ground level we are getting a stable signal. This thing was totally unbelievable to me. So let's go further. Getting a minus 116 dBm RSSI. So this is our entire circuit diagram. This is the transmitter Arduino code of our LoRa project. So in this video I am going to test range of this RYLR993 Lite LoRa modules come from REYAX Technologies, and I am also going to explain and provide you the Arduino codes and circuit diagram used in these projects. So if you are also interested in these projects in this LoRa module, stay tuned in this video, watch till end, and I can assure you, you will also be able to communicate more than 10 km using these LoRa modules. So stay tuned in this video and let's start. So this is the main LoRa module REYAX Technologies had sent me. This is REYAX RYLR993 Lite. Actually they had sent me two of these LoRa modules along with this high performance rubber ducky antennas. These antennas are very precise, I had checked them. Also they had sent me this UFL to SMA female connector because our LoRa modules have UFL connector, and to connect it with this antenna we need this. So now let's talk about our transmitter and receiver setup. This is our transmitter section. Here as a main microcontroller I had used a Arduino Nano. This is our main transmitting LoRa module, which is a REYAX RYLR993 Lite. This LoRa module's digital pin are only 3.3 volt supported. That's why I am using this logic level shifter here. And during transmission, this LoRa modules draws a significant amount of current. That's why I am using a external AMS 1117 3.3 volt regulator. Arduino Nano also have a onboard 3.3 volt regulator, but that current is not enough to power up transmitter LoRa module. I am powering up this entire transmitter using this 2-cell lithium-ion battery pack, and this is our receiver. And as you can see, its green LED is glowing now. It means currently it is receiving the transmitted signal from this transmitter module. Our receiver's LED is turned on now, and if I disconnect this transmitter from this battery, this LED will automatically turn off. It means this LED is glowing when this transmitter is transmitting. Again reconnecting this battery with this transmitter, and this LED will turn on automatically. And here also I had used a Arduino Nano. Again here is a logic level shifter, but here is no any external 3.3 volt regulator because during reception this LoRa module don't draw that much significant amount of current. And here this is our LoRa module. As you can see, I had not connected any kind of antenna with the receiver right now, but on the transmitter module I had connected this antenna. This is because this transmitter and receiver both are in very close proximity. If I also attach antenna with this receiver module, it can actually overload the power in the receiver LoRa and it can damage it. That's why I had removed this receiver antenna right now. But for long range communication this antenna is very important. But you also have to remember that never turn on your transmitter without any proper antenna, otherwise the reflected power can actually damage your LoRa module. Here I had also used a SD card module to log my incoming received signal and their signal report, because whenever this receiver will fly high in the sky under the drone, we cannot get live RSSI and SNR from this receiver. That's why I am logging those all datas in this SD card. If you want, you can also remove this. The program will run as it is. This thing is completely optional. For both transmitter and receiver section, the circuit diagram is almost same. This is the circuit diagram of this project. I will explain this circuit diagram along with its code later in this video. Also you can freely download this circuit diagram and this Arduino code. Link is already in the description. Go and check out this. So now let's explain what transmission and reception is going on here. This transmitter Arduino is sending a counting number 1, 2, 3, 4 to this receiver each and every second, and for each transmission this LED is glowing for 75 milliseconds. Also you have to take care about this transmission frequency. You have to set it according to your local laws and your country laws. In my country 865 MHz is a free ISM band up to 1 watt transmission power. That's why my modules are set in 865 MHz. As you can see, this is the signal peak. It's transmitting in properly 865 MHz. You have to follow your country laws and your local regulations. So this Arduino is sending the counting number, and this Arduino is receiving that counting number transmission using this receiver LoRa module, and this receiver is right now connected with the Arduino ID. As you can see in the serial monitor, here is our incoming data. This is the actual incoming data packet, this one, and this received number is our actual data payload which we are receiving from this transmitter module. and this is the RSSI. It means received signal strength indication. Our LoRa modules can go up to minus 148 dBm, and SNR means signal to noise ratio. Right now this SNR is minus 8 dB. I will explain the entire circuit diagram and Arduino codes later in the video. Also, circuit diagram and Arduino codes download link already in the description box. So please go and check out to download those. And this antenna will be our main transmitting antenna for this project. As you can see, this is a DIY dipole antenna for 865 to 868 MHz. Performance of this antenna is far better than any market available antennas. This antenna's reflection power is minus 40 dB, which is too good. I had mounted this antenna on my rooftop high in the sky so that we can get a clear line of sight up to very long distance, and we will fly our receiver under this drone. When this drone will fly high in the sky, our both transmitter and receiver LoRa antennas will come in line of sight. In that way we will be able to get a clear line of sight testing. So this is our complete LoRa testing setup. Now let's start the experiment. Before we start, big thanks to REYAX Technology for sponsoring today's video. They have kindly sent me those 2 LoRa modules for testing and experimentation, and this video is made possible because of their support. REYAX is a well-known company in the field of RF and wireless communication modules, GPS, GNSS, ultra-wideband modules, and their products are widely used in IoT and long-range communication projects. You will find REYAX official website link and their product purchasing link along with the product specification and datasheet link in the description below. So if you are interested, you can check them out directly. Once again, thanks to REYAX Technology for supporting this project. Now let's start our experiment. So here our receiver is already set up. Now I am going to power up this transmitter. As you can see, this transmitter antenna connector is connected with this DIY dipole antenna. Our receiver's green LED should turn on because our transmitter has already been started. As you can see, our receiver's green LED is turned on. It means receiver is receiving signal from this transmitter antenna. Transmitter antenna is transmitting using this dipole antenna. And if I show you, our transmitter is transmitting in proper 865 MHz. Now I will go away from this transmitter antenna and attach this receiver under this quadcopter and fly high in the sky. And in this way, we will get a clear line of sight in these LoRa modules. So let's go and see how far we can actually communicate using these REYAX LoRa modules. So this place is more than 3.1 km away from our transmitter antenna, and from ground level we are getting a stable signal. As you can see, the receiver's LED is glowing constantly green. It means we don't have to fly our drone also high in the sky. Don't need any kind of line of sight. As you can see this side, our transmitter antenna is somehow this side, and we are getting a stable signal from ground level also. Now let's check the RSSI and SNR from this SD card. So these are the current receptions. As you can see, we are getting a RSSI of minus 116 and SNR of minus 30. These modules can go up to minus 148 dBm. It means we can test these modules in further distance, and we have also fly our drone to get a better RSSI. So let's see how far we can go. So this place is more than 5.8 km away from our transmitter antenna, and from here also we are getting a stable signal from ground level. We don't have to fly our drone in the high sky also. So I am really stunned with the performance of this REYAX LoRa module. So these are the recent received data packets. As you can see, we are getting a RSSI of minus 116 dB and SNR is minus 17. So still we can test out this module in further distance. I don't know how far we can communicate using this from ground level, and then we will also fly our drone to get a better range. So let's see how far we can communicate. So this place is more than 7.3 km away from our transmitter antenna, and from ground level we are not getting a stable signal. Sometimes we are getting a green signal. So this time let's fly our drone from here and let's see if we can communicate with our transmitter antenna with a stable connectivity or not. So as you can see, our drone is not very high in the sky, but still we are getting a stable signal from 7.3 km away. It means if we set our receiver on top of a building or a tree, we can easily get a very good stable signal from 7.3 km also. Now let's go further and see how far we can communicate. So I just arranged this antenna as a reflector of this drone, and as you can see, still we are getting a stable signal using this. You can see this green LED. So I don't know really how much powerful these LoRa modules really are. From 7.3 km away, our RSSI is around minus 1125 dBm and SNR is minus 17 dB. So our LoRa module can communicate in further distance also. As you can see, our all data packets are intact. So this place is more than 10 km away from our transmitter antenna, and here also from ground level we are getting a stable signal. As you can see, this thing was totally unbelievable to me. With this LoRa modules, my drone is just useless. We don't need any kind of line of sight to get a stable signal with this beautiful REYAX LoRa module. As you can see, this green LED is glowing constantly. Now let's check our RSSI and SNR using the laptop. I am going to disconnect this receiver LoRa from this battery, and this is our SD card. Inside this, our received signal has been recorded already. So from 10 km away, as you can see, our RSSI has not changed very much. It's minus 116 dBm and SNR is minus 12 dB. So it's the second day of our experiment, and again we are in the similar place. This place is more than 10 km away, and you may ask me why I am again here. Because in any scientific experiment, repeatability is very much important. So I came here again to check if our today's result is similar to the yesterday or not. And if I keep this antenna high in the sky, as you can see, this green LED is constantly glowing. It means today also we are getting a stable signal from ground level by holding this antenna just in my hand. You can again see the constant green LED. It means more than 10 km is also not a problem for this module from ground level, but you have to keep your transmitter antenna high in the sky. I had shown you my transmitter antenna arrangement. From 10 km away, today also we are getting a minus 116 dBm RSSI. So it means our today's result is very similar to our yesterday's result. And we can test this LoRa module in further distance. So let's go further distance and check if we can communicate in more than 10 km or not. So currently this place is more than 15 km away from our transmitter antenna. And again, if I hold my antenna in my hand, as you can see, we are getting an unstable connection sometimes. If I move a bit, this connection is actually not stable. So from here, I am going to fly my drone high in the sky, and let's see if we get a stable communication using this drone or not. So I think due to this dense vegetation of this place, we are unable to get stable signal from the ground level. That's why I am preparing my drone. I will fly this receiver under the drone high in the sky, and I hope we will get a stable signal from sky. So as you can see, we are getting a stable signal using our quadcopter. It means due to this dense vegetation, we are unable to get signal from this ground level. I think otherwise we will also be able to get signal from ground level. So now let's land our drone. And this is the data from 15 km away. As you can see, the RSSI result is extremely good, minus 114 dBm, better than actually 10 km away. So I think we can also communicate very easily using this LoRa module up to 20 km, or if we get more than 20 km, I will really not be stunned. So conclusion of this video is, using this RYLR993 Lite LoRa module, we can communicate in more than 15 km distance. Actually, it's not possible to me to run this experiment more than 15 km. Already it's the second day of this experiment and it's very cold outside. My transmitter LoRa antenna is on my rooftop around 25 meter above the ground level, and up to 14 km we are able to get the signal from ground level just by holding our antenna on my hand. And I think this 15 km area is due to very dense vegetation. We were unable to get signal from ground level. That's why we fly our receiver under this drone, and the drone's height was also not very much. So if all conditions are okay, in that case we should get a stable connectivity from ground level also for more than 15 km. And I think if you run this experiment in more than 15 km using this quadcopter, or our receiver LoRa node is high in the sky on top of a building or any tree, I think we should get a clear communication up to more than 20 km. So I had tested more than 15 km and the test result is very good. REYAX LoRa module are really amazing. I had tested this in real life and I had also shown you with proof. So from my side, these REYAX LoRas are one of the best I had tested ever. Many people message me or comment me in my comment section that they are not getting good range using LoRa module. They are struggling to get only 100 meters range out of this LoRa module. But I want to say them, LoRa modules are not made to be transmitted in very dense vegetation or inside a urban area from ground level. I had also set up my transmitter antenna on an urban area, but as you had seen, I had placed my transmitter antenna high in the sky. That's why up to 14 km I was able to get a stable signal from ground level also, although I was using a omnidirectional transmitter and receiver both antennas. So who are not getting good range in LoRa module, for them my suggestion is, please place your antenna on a rooftop or high from the ground and it will increase your range significantly.
Okay, so at first let's explain our circuit diagram, then I will explain our both transmitter and receiver code. So this is our entire circuit diagram. There are very few components, as you can see. This is our main microcontroller, which is Arduino Nano in this case. This is our LoRa module. This schematic is both for transmitter and receiver. The connections are all same. Only in the receiver section, if you want, you can attach this SD card module. I had written the code in a such way so that if you don't connect the SD card module, the entire code will run as it is, and if you attach a SD card module, it will also save your received signal information in the SD card. So this is completely optional for you, and this is the main part. So this is our main microcontroller Arduino Nano. This is the LoRa module REYLR993 Lite, and this is a logic level shifter. Always remember, this LoRa module's signal pins are only 3.3 volt tolerant, and Arduino have a 5 volt logic level. So if you directly connect this kind of LoRa module with the Arduino Nano, it will actually destroy your LoRa module. That's why you need a logic level shifter like this. In one side of logic level shifter, this is high voltage side and another is actually low voltage side. Or if you have ESP32 or Raspberry Pi Pico or this kind of microcontrollers which logic level is 3.3 volt, you can directly connect in that case your LoRa module with your that kind of 3.3 volt microcontrollers. So here we are using Arduino Nano, which is a 5 volt one. That's why I am using this logic level shifter. And this is our indicator LED here, as you can see, and this is a reverse polarity protection diode, Schottky diode, which is 1 in 5819. Here I had made a table so that you can clearly understand the connection between the microcontroller and your devices. Arduino Nano's digital pin 7 is acting as a software serial RX pin. That's why it is connected with the LoRa module's TX pin. So this is our digital pin 7, and as you can see through the logic level shifter, it is connected with the TX pin of the LoRa module. And Arduino Nano's digital pin 8 is acting as a software serial TX, which is connected with the LoRa module's RX. So this is digital pin 8, as you can see through the logic level shifter, it is connected with the RX of the LoRa module. And our LoRa module operates on 3.3 volt power supply. So Arduino Nano's onboard 3.3 volt power supply is not enough to power up this LoRa module, because during transmission this LoRa module draws a significant amount of current. That's why here we are using a simple 5 volt to 3.3 volt regulator, which is AMS 1117 3.3 volt, and that kind of, you can use any of them. Just don't use any kind of PWM or SMPS based buck converter, because they can create signal noise around the LoRa module, or they can actually create noise in the power supply of the LoRa module, which can finally cause some issue with this LoRa modules, because radio frequency modules are very sensitive towards power supply noise or other kind of noise. So input side of this voltage regulator is connected with the 5 volt of Arduino Nano, and output we are getting 3.3 volt, which is directly connected with the VDD of the REYAX LoRa module. Also from this 3.3 volt output, we are putting it in the logic level shifter's low voltage side, and the high voltage VCC side of the logic level shifter is connected with the Arduino's 5 volt. Both grounds are sorted together and connected with the ground of the Arduino Nano, and that's it, the connection of this LoRa module with Arduino. So between the Arduino Nano and the REYAX LoRa module, there is a logic level shifter, and we are powering up this LoRa module using this 5 volt to 3.3 volt voltage regulator. So we are powering up this Arduino Nano using this VIN pin, and here is a reverse polarity protection diode, as I had told you before. Sorry, I had done a small mistake. Actually, we have to connect this LED in D5 pin of the Arduino Nano according to my previous code, but previously I had connected this LED on the D6 pin of the schematic, so I had already corrected it. So as you can see here, D5 of Arduino Nano is connected with the LED. For both transmitter and receiver, these all things are same, And if you want to log your received signal data and signal strength and related other stuffs, you can also use a SD card module here. So here is the connection between the Arduino Nano and the SD card modules. Remember, there are lots of SD card modules available in the market. You have to check your modules properly. My SD card module comes with a onboard 5.5 volt to 3.3 volt logic level shifter. So I had directly connected my SD card module with the Arduino Nano. So SD card modules MOSI will be connected with Arduino's D11, MISO will be connected with D12, SCK will be connected with D13. SD card modules chip select is connected with digital pin 10. So this much connection only, and my SD card module powers up using 5 volt power supply. That's why I had connected it directly with the Arduino's 5 volt pin, and ground is going to ground. So this is the entire circuit diagram. I hope you can understand properly. I am also attaching the download link of this circuit diagram in the description box. If you want, you can download it from there. Here I had properly explained each and every connection, so you should not face any kind of problem. Still, if you are facing any kind of problem, my Instagram ID's link is also in the description box. Message me there and I will solve your problem. Now let's explain our transmitter and receiver code. So this is the transmitter Arduino code of our LoRa project. So as you can see, only one library we had used here, which is software serial.h, and here we had defined the software serial pins which we are using in this project, which is digital pin 7 as a receiver pin and digital pin 8 as a transmitter pin. And here we had defined the LED pin of the Arduino. If you want, you can also change it here. And here are some important parameters right now. If you want to configure your LoRa module, you have to do these things. This is the line where we are setting up the operating frequency of this LoRa module. You have to set this frequency according to your local laws and your country's free ISM band list. So for me it's 865 megahertz, which is a license free band. That's why I am using this. You can change this number according to your local regulations. And here are some other parameters which are very important if you want to communicate in a very long range or in a very high speed. So this first one is spreading factor or SF, the second one is bandwidth, the third one is actually this CR, and the fourth one is CRC. The most two important things are this spreading factor and this bandwidth. With a higher bandwidth we can get higher data rate, but our effective range decreases. With a narrower bandwidth we can communicate slower, but it can communicate in a long range. If you increase the spreading factor number, it will take a long time to transmit a similar string comparing with a lower spreading factor number. But spreading factor really helps when you want to communicate in a very long distance, and as you can see in my video, I was able to get a stable connectivity from ground level up to 10 km or further distance. That's because I had setted this spreading factor at 10. The beginning number is 7 and the ending number is 12. You can choose any number between these two numbers. So I had chosen 10 and I got a fairly good result, you can say. And these are some other parameters. You don't have to think very much about them. One thing more, this address is very important for REYAX modules communication. Your transmitter module should be 1 and receiver module should be 2. Okay, so your transmitter LoRa module will send the data to your number 2 address receiver module. If your transmitter is trying to send data in a particular address and your receiver is in another address, you will never be able to communicate between these two modules. So this is an important factor, and other things are not that much important for you. Although this entire code is very well documented, if you read these all comment lines, you will automatically understand what this lines actually does. So this is the main part when our data is being transmitted. See this 80 plus send 23134. So this number 2 is the our receiver LoRa module's address, which I had explained a few times before. Here our transmitter's address is 1 and our receiver LoRa module's address will be 2. So this is here. If your receiver LoRa module's address is 3, 4 or anything, you have to change it here. So with a transmitter module, you can separately send multiple datas to multiple receivers if they all are set in another different addresses, or if they all have a same address. In that case, all of them will be able to receive the same transmitted signal. So that's it for this transmitter code. As you can see, this is the 75 millisecond LED blinking part, and our code ends here more or less. So this was the transmitter code. Now let's explain the receiver code also. This is our receiver code. Always remember these configurations I mean the operating frequency, spreading factor, CRC, and these all things are very important in LoRa communication. Both transmitter and receiver, they should be exactly same in these parameters, otherwise your transmitter and receiver will never be communicate. Remember this frequency and these factors, these all should be same, and your address should be proper. Okay, so in the receiver code also, again we are using software serial.h library, and here, as you know, we are using a SD card to log our received data. That's why there are two more libraries, sg.h and spi.h. Our SD card communicates with our Arduino Nano using SPI protocol. That's why there is also spi.h. Here again we are defining our software serials pins, digital pin 7 as a receiver pin and digital pin 8 as a transmitter pin. And here we are defining our CS pin of the SD card, which is digital pin 10. This is again the output LED's pin number, which is 5. And here again we are setting up our LoRa module. As you can see, you have to keep both of your LoRa modules in same frequency, which is 865 megahertz here also. And as you can see, the all parameters are also same. Spreading factor is same 10 as with our transmitter code. The bandwidth is 125 again, CRC is on, and these are add. Remember, I had told you during the transmitter code explanation that we are sending that data particularly to number 2 address LoRa module. So this LoRa module, we are setting its address as 2. So any data that has been sent to a number 2 LoRa module, it can be able to receive that. And the rest part is just receiving data from incoming LoRa module and split them in different parts, as you can see here, and showing on the display that this is the received data, this is RSSI, this is SNR, and everything which I had already shown you in my previous serial monitor part or setup part, whatever you can say. I am also giving you this both transmitter and receiver codes download link in the description box. Please check out the description box to download both of this transmitter receiver code along with the circuit diagram. And again I am saying, if you face any kind of issue or if you have any kind of questions, queries or anything regarding this project, these codes or circuit diagram or anything, my Instagram ID's link is already in the description box. Message me there and I will solve your problem.
So that's it for this video. Hi, I am AkashWave, call sign Victor Uniform number 3 Hotel Alpha X-ray. I am an electronics and communication engineer and a licensed ham radio operator also. Now I am pursuing my MTech on microwave technologies. I used to make videos on microcontrollers, microprocessor, sensor, RF modules, especially LoRa, ham radio, antenna making, RC hobby, RC drone, plane and this kind of stuffs. If you are also interested in these topics, stay tuned in this channel, consider subscribing and hope you like this video. If yes, please press the like button. If you have any kind of questions, queries, suggestion or anything regarding this video, let me know in the comment section or you can directly message me on Instagram. My Instagram ID is already in the description box. As always, circuit diagram and Arduino codes used in this project already in the description box. You can download them from there. You can also visit REYAX Technology's website from my description box, and also I have provided the purchasing link of this LoRa module, so you can check them out. So that's it for today. See you in another video. Bye.